Well, to finish up this section, we are going to talk briefly about an X-intercept and a Y-intercept. Well, first let's define them. What is an X-intercept of a graph? I'll make an abbreviated definition here. For the X-intercept, I'll say it is where the graph, I'm going to use the word hits the x-axis. I was going to say where it crosses the x-axis, but it doesn't have to cross it to be an X-intercept. It could just go down and touch it and go right back up. So I just used that word hits. It's not really a mathematical term, but you know what I mean. It's where the graph intersects the x-axis. And similarly, for the Y-intercept, it's where the graph, maybe I'll use the word intersects this time, intersects the y-axis. Okay, so let's say we've got these two graphs. They're already done for us. Let's identify the x-intercepts and the y-intercepts. This is pretty easy. Actually, I'll go identify them. I'll go circle them. Those are the x-axis, the x-intercepts, because that's where they intersect with the x-axis. And this would be the y-axis right here. So maybe I will call, I think the x-intercepts are easy. Negative 1, 2, 3, 4, 5. Negative 5 and 1, 2, 3, 4. And positive 5. And then the y-intercept is, I'm going to say, I think my intention was to make it right in between there, so I'm going to call it 2.5. 2.5. Actually looks maybe closer to 2.4, but you get the idea. Okay, and in this graph, we've got x-intercept, 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 and then one y-intercept right there. 3 x-intercepts I will write as negative 1, 2, 3, 4, 5, 6. Negative 6. That looks roughly between negative 1 and negative 2. I'm going to call it negative 1.5. Maybe I'll use a fraction on this one. Negative 3 over 2. Negative 1.5. And the third one is 1, 2, 3, 4, 5, 6, 7, 8. Positive 8. And then for the one y-intercept, where does it cross the y-axis? Right there at negative 1. All right, well, suppose you do not have the graph. You're given the equation. How do you find the x-intercepts and y-intercepts of a given function or an equation without graphing it? Well, for the x-intercept, set y equals 0, solve for x. Simple as that. How do you find the y-intercept? Set x equals 0, solve for y, and that's how you get it. Okay, let's do one quick example. Now this is a function which I haven't really talked about functions, but usually f of x just means you can replace that with y. So this is our equation that we are going to find the x and y intercepts of. Y equals negative 4x minus 10. So let's find the x-intercept. Set y equal to 0. So that means 0 equals negative 4x minus 10. Solve it for x, and that'll give us the x-intercept. So if we add 10 to both sides, add 10 to both sides, that's what we get. And then, to get x by itself, divide both sides by negative 4. And that means that x equals 10 over negative 4, which I'm going to reduce to be negative 5 over 2. So that's the x-intercept of this equation. The y-intercept of the equation, that'll probably even be easier. What do? To get the y-intercept, you set x equal to 0 and solve for y. So y equals negative 4 times 0 minus 10. Well, that term is just 0. So y equals negative 10, and the y-intercept for this equation is negative 10.